All right, welcome back. Today we are going to look at two problems using Newton's law of gravitation. So this first one, we have moops and meeps. They're floating in space. How far apart are they if they are 9 times 10 to the negative 10 newtons of force between the two of them? So the first step, as always, I'm going to write down what I know. I know M1. I have a second mass, so I'll call M2. I'm trying to figure out how far apart. So how far apart is my R? And I have a force of gravity, which is 9 times 10 to the negative 10 newtons. Okay, so that's what I know. I have an equation, which is big G, M1, M2 over R squared. And if you recall, big G is the gravitational constant. It is always that 6.67 times 10 to the negative 11. So I am going to plug my numbers in. So I will have 9 times 10 to the negative 10 equals 6.67 times 10 to the negative 11 times 12 times 8 divided by R squared. So I have R in the denominator, and I don't like that very much. So to get it out, for this one, I'm going to cross multiply. So I'm going to put this over a 1. So I'll have R squared times 9 times 10 to the negative 10 equals 6.67 times 10 to the negative 11 times 12 times 8. All right, so now I'm trying to get R by itself. So I'm going to divide both sides by 9 times 10 to the negative 10. So that will cancel. So I will have R squared to be equal to 6.67 10 to the negative 11 times 12 times 8 divided by 9 times 10 to the negative 10. And the final thing I'm going to do to solve this is I'm going to take the square root of both sides to get R. So I will have, finally, R equals the square root of 6.67 times 10 to the negative 11 times 12 times 8 divided by 9 times 10 to the negative 10. And when I plug this into the calculator, I keep in mind that, for example, 6.67 times 10 to the negative 11, it's going to equal 6.67 e to the negative 11 is how you put this in the calculator. So you would write that in the calculator instead of that. So when I put this all in the calculator correctly, I'll get a value of 2.67. And because R is a distance, my units are meters. So that's my final answer, 2.67. Okay, let's do one more problem. For this one, we're trying to find the force acting on the middle object. And so what I'm going to do is I am going to look at the left side. I'm going to look at the 10 kilogram object and the 2 kilogram object. I'm going to find the gravitational force between those two. I'm going to ignore the 3 kilogram object on the right. So I'm going to use the same equation. I'm going to say the force of gravity between object 10 and object 2. So I'll put 10 with a little space and a 2. So the force between those two will be big G to the negative 11 times my two masses divided by my r squared. And I put that in the calculator, and I find that the force between those two objects is 8.34 times 10 to the negative 11 newtons. All right, so I'm going to do the same thing, but this time I'm going to look at the right side, and I'm going to look at the forces between objects 2 and 3. So I'll label that as 2 and a 3. This is the force on the right side. And I'm going to say the same thing. G, always the same. I have two masses. This time my masses are 2 kilograms and 3 kilograms on the right side. And I'm dividing it by the distance between the objects 2 and 3. It's 6 squared. And I put that in a calculator, and I get 1.11 times 10 to the negative 11 newtons. So really what I'm looking at, if I go back up here, this 2 kilogram object in the middle is getting tugged in two directions. It's getting pulled to the left by this object, and it's getting pulled by 8.34 times 10 to the negative 11. This is the force. And I would call this negative because it's getting pulled to the left. So I do have to force this negative in here. And then it's getting pulled to the right by the 3 kilogram object, and it's getting pulled to the right with a force of 1.11 times 10 to the negative 11 newtons. So it's getting pulled both ways. And I can see that the one on the left is stronger because it has a force of 8, and the one on the right is weaker as a force of 1. I can also tell because the mass on the left is bigger, the 10 compared to the 3, and the distance is smaller because they're closer together, 4 meters compared to 6 meters. So the object on the left is definitely pulling it stronger. So because they're pulling against each other, we're going to subtract these two, or basically add them together, but because one is negative, it will work out. So we have negative 8.34 times 10 to the negative 11 plus 1.11 times 10 to the negative 11. And we add those together to get a final answer of 7.22 times 10 to the negative 11 newtons. And that is our final answer. So basically, we're using our equation for Newton's law of gravitation twice. We're doing it once for the left, between the left two objects. We're doing it a second time for the right, between the right two objects. And because they're pulling in opposite directions, we have to subtract them at the end to get our net force. All right, thank you very much.